It's an IIPMT 2004 from the Center of Mass Concept. The problem is like this. Consider a system of two particles having masses m1 and m2. If the particle of m1 is pushed towards the center of mass of the particle through a distance d, by what distance would be the particle of m2 has to be moved to keep the mass of the center of mass in original position? Let us try to understand what he is saying. There is a particle of mass m1, another particle of mass m2. Their center of mass is somewhere, maybe from m1 at a distance r1, from m2 at a distance r2. So we can say first center of mass initially is m1 r1 plus m2 r2 by m1 plus m2. This is a known derivation for us. Now what he said is, when the first particle m1 is pushed towards the center of mass through a distance d, this is now moved. It's here by distance d1. So because of this, center of mass is tended to shift right. To balance that, this has to be moved away. M2 also has to be moved away by some another unknown distance, say some x. What is that? So that the center of mass remains same is the question, right? So if I have to draw the new diagram, your M1 is somewhere, your M2 is also somewhere. From the original center of mass, M1 is at a distance of R1 minus D, because this entire distance is R1, out of which D1 is moved forward. This center second distance will be R2 plus x, because it is moved beyond that point. R2 plus x. What is that x? So that the center of mass remains the same is the question. New center of mass equation we can write as m1 of R1 minus D plus m2 of R2 plus x by m1 plus m2. What this question is, by how much I have to move to keep the center of mass at a original position. That implies center of mass of the first case equal to center of mass of the second case. So I can equate this equation and this equation. Equate them, see what happens. M1 R1 plus M2 R2 by M1 plus M2 equal to M1 of R1 minus D plus M2 of R2 plus X by M1 plus M2. This M1 plus M2 can be cancelled. Let us simplify this equation further. M1 R1 plus M2 R2 equal to, multiply here, M1 R1 minus M1 D plus, multiply here, M2 R2 plus M2 X. M1 R1, M2 R2 is there on both the sides, they can be cancelled. So 0 equal to minus M1 D plus M2 X. That implies M2 X equal to M1 D. X equal to M1 D by M2. So you shall move this second particle away by this much of the distance, so that the center of mass remains same, remains at the original position. So your answer has to be this, M1 by M2 of D. That's the right answer to solve this problem. So this is a very simple problem. To solve this, you need to know only what is center of mass formula is. Once you know, you are good to go. That's how we have to solve the problem. Thank you for watching.